all, welcome to Corpnce. I'm Rono Savio, and in this video we are going to discuss about the unordered containers of Python. That's nothing but set and dictionaries. Before we jump into these topics, let's see why they are called as unordered containers. So if you see in tuple or list, which are known as the ordered containers of Python, you can see that each values in those containers are assigned with index positions respectively in a particular sequence or an order. So if you try to access a of 0 in a particular list or a tuple, you can see that the first value of that container is being accessed. If you say a of 1, the second value is accessed. But try the same thing in unordered containers of set and dictionary, you will get an error. The reason is you don't have any particular index positions assigned in a set or a dictionary. They have been stored in a particular way called as hashing, which we'll be talking about later. And we will start with the first unordered container, set. We'll be discussing how set works. Let's see our first unordered container, which is set. How do we declare a set? We declare a set using flower brackets. So here if I say A and we have a flower bracket like this, now you must be assuming that this flower brackets, there is nothing inside this, so this should be an empty set. But notice that even though you are declaring a set with flower brackets, if at all you are trying to declare an empty set, if at all you check the type of A, you can see it is a dictionary, because even though set is also declared in flower brackets, even a dictionary is also declared in flower brackets. So make sure if at all you are trying to declare an empty set, you go with this particular syntax. Now it's a set. And if at all you have multiple values or elements to be held in a set, then you can go with this particular format. And I told you set is known as one of the unordered container of Python. Why it is known as unordered container? If at all you try to access value like this, let's say a of 0, and you do this, you see set will throw an error. Yeah, type error. And type error says set object is not subscriptable. If you have focused on dunder methods, I told you dunder methods are the core behavior of Python, and there is a dunder method called as getItem, which helps you to access value. And if you check the directory of directory of set, if I check it, I think I'll print it. It's coming vertically, I want it horizontally, so I'm going to say print dir of A. And yeah, here you can see that I have all these dunder methods and class getItem is different, but the double underscore getItem, which helps you to access value, is missing from this particular container. Yeah, that's the reason why you are not able to access value, and that is also the reason why your container, this particular container set, is called as unordered container, because whatever elements you are storing, it is stored in the memory using hashing, in the format of hashing. So what do I mean by hashing? Every immutable data types can be stored in your set. So here when I say print hash of 2, this is fine, this is random number. 2 hash of 2 is nothing but 2, but let's say you try to put a string is immutable, if you know, and you get a particular number, and your set also keeps track of the values by using this hash values in the memory. And this is exactly how you can store in this particular set too. So if at all you try to store a tuple or a string, it really works fine. Even a boolean too, it works totally fine. If I say true, this is a string, but anyways, see, it works pretty fine. And if at all I store something which is, mutable, changeable, let's say for example list, if I try to store a list inside this particular container, I'll say I can store empty list, but let's keep some values, and if I run this, you see unhashable type list, because list is mutable, it is not fixed, it keeps changing, that is why it is unhashable. But let's say it's a set, it's a tuple, the tuples are fixed, right? There won't be any change in them. So if I run this, it works pretty fine. So set holds unique values. So what do I mean? Unique elements. So if at all you have repetitions, let's say you have 1 2 3 4 5, and if I go with again 5 5 5 5 5, okay, there's a lot of 5s here, and if I print my set, you can see that it is only giving 1 5, the unique values, and the repetitions are neglected. So this is how set works. This is the basics of how your unordered container set works. And there are some functions that you will see, like to manipulate set, and set can, even though you cannot access values using the syntax like you use in the order container for list and tuples, you can still access values using the built-in methods for set. So we'll see that. I'm creating one more set, and I'm naming it as variable b, and that variable b I'm gonna give 4 5. Okay, two values inside this container, and I'm saying this A is known as superset of B, superset of B, and B is known as subset of A. I think this is very clear. The reason why I'm saying B is a subset of A is because 4 and 5, whatever values is there in B, is present in the superset A. The reason why it's a superset of B. And yeah, I have to, okay, now I am telling this to you. But let's say, how do Python know that it is a superset or a subset? There is actually methods which you can use in set. So A dot, you can see here, is subset of B. Okay, I'm using a method called is subset, and I'm going to print it. So if I print this method gives me a boolean value, true or false, and I'm running it and I'm getting false, which is right, because A is not the subset of B. B is the subset of A, right? I've mentioned it in the comment, subset of A. B is actually the subset. I just print in the next line saying B dot is subset of A. Yeah, you can see the second line output is true. So this is how you can find out if a particular set is actually a subset or a superset. So to find superset, you can't use this method. You have one more method called as is superset. So I'm saying B dot is superset of A, and you can see that I'm clearly giving the wrong thing, because B is not the superset of A. A is actually the superset of B. It's other way around. And if I run this, yeah, this also gives me a boolean value, and what I expect is false, and it has given me false. If I say A dot is superset of B, if I run it, I'm getting true. Okay, so it's working pretty good. Now there are many other methods too. This is just to check if it is a subset or a superset, and it's working pretty good. Now we will try out different methods of this particular set. So let's explore some. So if I'm saying A dot, I have update, remove, add, discard. Let's go with update. So if you want to update your particular set with multiple values, so update is used to update a set with the union of itself and others. So you don't have to worry much about what this means by union and itself and others and all. I'll explain you. So if at all you want to add multiple values, okay, I'm giving multiple arguments here, but you can see in the doc string it says iterable. So make sure this is a particular iterable. It can be a list also, it can be a set, it doesn't matter, it should be an iterable. So you can iterate through values. Now I'm updating this particular A. Oh, you don't see the updated values because set holds unique items. I'll just keep this very unique, then 109, let's keep it 28, let's keep it 33, 4, 5, it's fine. Now you can see that it has been updated to whatever you wanted. That is how update works. And make sure you don't give it multiple arguments like this without iterable. You will get an error obviously. So int object is not iterable. It doesn't care of that. It just wants iterables. And next one, what we are going to see is, yeah, let's see, remove. Okay, fine, we will remove some values. So here removes an element from a set. It must be a member. If the element is not a member, you will get an error. So that's a key error that you want to get. So if I say 2003, yeah, key error, what I expected. But if I say 2, that's also a key error. Let's add 2 here. Yeah, it worked pretty good. Let me check. Yeah, 3 is actually removed from that particular set that we desired, and yeah, it's working pretty good. And let's try copy. Copy is very simple. You just take a copy of the particular container. I'm going to paste it here. I'm saying a dot copy, and this copy what you're taking, assign it to a particular variable so you can use it. And now if I print B, you can see it took the copy of the particular container A. It is the same container, don't worry, it's just taking the unique values. So if I change something in B, so okay, before that, how do I change value? Okay, I'll just use update. because I have not taught you add yet. So update, take some iterables, 9, 8, 7. Okay, now I'll print B again. Okay, print A first because we have to check if A is proper. Yeah, so A is unharmed, it's not touched at all, it is as it is. But B here, we have changed it and it's changed, it's working pretty good. Good. I hope this one's clear how you take a copy of it. So you want to keep your set intact. And there is something called as frozen set, which I'll tell you in the last function, which is a frozen set. We'll see it. Okay, cut that part, okay. Yeah, that's what I was saying. So yeah, there is something also called as frozen set, which will actually keep your particular set mutable, where you cannot change the values. Like how I'm updating here, you cannot actually do that when you are converting your set into a frozen set. I'll teach you that later, but we'll finish the functions first. So we actually saw this, copy now, and we'll see a difference. When you are actually taking difference, let's say A difference B. Okay, you need to set here, so I'm gonna paste it here, and I'm saying B also, it's gonna be 3, 4. Now you see there is a common term, 3 and 4 are common, but 1 and 5 is unique for B, which is not present in B. So now if I run this, you can see I'm getting 1, 5. So the difference, whatever difference is in A, but not in B. So 3, 4 is very common, because A also has it, B also has it. But 1 and 5, it's not present in B, but it's present in A. There's a reason why when you give A difference B, you are getting 1, 5. You can see that. I think I'll run. This is more simple, right? Yeah. Now if I wanted to go with symmetric difference, there's something called a symmetric difference. So A dot symmetric difference. Okay, and I'm going to say B. Now what happens is that whatever values are unique in A and unique in B. So here 1, 5 is unique for B, and there is, I'll add some values like 38 and 56, not M, it's comma. Okay. So symmetric difference. What is there in B but not in A? What is there in A but not in B? That is what your symmetric difference gives you. And you have symmetric difference update, sorry, not outdate. A dot update. Difference update is there. Here what happens is that, take this particular, okay. Now I'm updating this difference. So whatever difference you have, the unique difference you have in A will only be present in A. It won't have 3 and 4, which is common in B. So difference actually takes the difference between A and B, which was there in A but not in B, takes that unique one. Here the same thing it will take, but it will update that particular A with only that values. If I run this, it's running fine. If I say A, you can see the A, particular set A we had, it had 1, 3, 5, 4, but now it is only having 1 and 5. That's how difference update works. You are updating the particular set. You are seeing the difference and you are saying updated with that difference. Okay. Then we have also symmetric difference update is also there. So A dot symmetric difference update B, and yeah, this also works exact same way. Your A has been updated for symmetric difference, and yeah, this is how it works. Now this is done. Next what we have is clear is very simple. I think I'll go with discard now, or maybe I'll try add. Add is very simple. So here you see add an element to a set. You just add one element to a set. This has no effect if the element is already present. So element means integer. What if you try to add float? We'll try. We always do 45.78678. You can keep the floating point very less, it's okay. And I want to see if it is added. It works. It doesn't matter, as long as your values are unique, it's totally fine. And yeah, this integer is hashable or float is hashable. Let's try string. Will string work? Let's see. Okay, T-A-P, tape. I don't know why. Tape, it works. What about an iterable? I want to add a whole set itself. I mean, yeah, let's add some to, I don't know, unhashable type set. Set itself is unhashable. So what do I do by this? I think I'll go with list. List also doesn't work. Yeah, it is also unhashable. Set itself is unhashable. Did you notice that? Because even set, when you're creating, you can add, your set can change. Because whatever values you hold inside a set, it wants it to be unique. But whatever set you have inside the set can be changed. Like you can add values, you can remove values. That is the reason why even set itself cannot be added inside a set. So yeah, only unhashable types work, like integers and float or boolean. Even boolean works, you can see. When boolean works pretty fine. But where is boolean? See that? The reason you are not seeing true is because true is considered as 1. You already have 1 here present. So let's say I remove this 1. Now I run it. I have true. Because true and 1 are considered as same when it comes to set or many of the data types. It is considered as 1 and false is considered as 0. I'll show you false. It takes like this, but let's say I have a 0 here. Where did false go? That 0 is nothing but your false. It has taken the unique value, and number has more weightage compared to this boolean values when you are adding to a set. Okay, so next one what you're going to see is, we have seen difference update, intersection. Okay, we'll see intersection. So here next one what you're going to see is intersection. So I'm saying A intersection B. So whatever values are in A and B, the common ones. So we can see that 3 and 4 are the common ones that we have in A and B. That's why we're getting A intersection B as 3 and 4. And let's say A intersection update. So yeah, A dot intersection update, right? Update B. So now what happens? Your A will get updated to whatever unique, common values were there in B and A. So now if I print A, you can see that A was actually 1, 3, 5, 4 and it has been updated to 3 and 4, the common values between A and B. This is how intersection update works. Now let's say you want to find if A and B are completely different. So there's some method called as disjoint, A disjoint B. I'm going to get false because A and B are not completely different sets, because A has 3 and 4 and B also has 3 and 4, which is common between them. Now I'll change this 3 and 4 to 39 and 40 just to make it very different from A. Now I'm getting true. So this method is actually helping you to find if a particular set is completely different. It's disjoint, it's not joint at all, like that. So yeah, this is one which helps you do that. And there is also one function called as pop. So popping the values. If I say a dot pop, it's gonna pop integer actually. You can see here it pops integer. And so it's gonna return you. It has popped the first value by default. It is 1. If I give a particular value 3, it says type error. Set.pop takes no argument but one given. So you cannot give values inside this. It only pops from the left side starting. It keeps on going like that. First come first serve, like that. So a.pop. And let's try remove. I think I already went with remove. Discard. Okay. What's the difference between remove and discard? So remove an element from a set if it's a member. Unlike set.remove, the discard method does not raise an exception when an element is missing from the set. So whenever you are using .remove, it raises an exception. This particular element is not there, why you are telling me to remove. That's how .remove works. But let's say .discard, if at all I give something like 345 which is not there, it works pretty fine. It is like totally fine if at all it's not present. So yeah, if at all 3 is there in discard, okay, for A, And if I print A 145, because the 3 is removed, and don't mind the order, it is giving it in ascending order, don't worry. And yeah, that's one more method that you saw for set. Then union is there. So union, it includes all the values 1 3 4 5 1 3 4 5, but you have to give it B 1 3 4 5 38 56. Yeah, I forgot to include B, that's why you got only for the value A. Make sure you include B2 in the union. So A union B, you join two sets together and took the unique out of it. Now that you see the methods that you can use on set, there is also something called as frozen set. So all these methods help you to add, remove, pop. You are manipulating with the set very well. But let's say you want to keep your set immutable, like you don't want to change the values inside it. Then let's say you have this particular set here. You just need set A, but I'm gonna make it a frozen set. I'm saying frozen set, and I'm gonna pass the set inside this particular. Now A is a frozen set of whatever it is. So I'll say A of 0. I mean, we cannot do that, right? So I'm saying A dot add. What I'm gonna add? I'm gonna add 30. Let's try it. And I'm gonna get frozen set object has no attribute add, so it's not letting me add or anything. So frozen set works exactly like a set, but you cannot change the value. Now let's say I want to compare it with intersection or something. Let's say I have 2 3 4, and now I'm saying A dot intersection B. This works pretty fine. See, all other methods work pretty fine except the methods that you are trying to alter this particular set. So frozen set keeps your set frozen, or let's say immutable. You cannot change the values.